नमस्कार बच्चों। मेरा नाम धन्या और आज हम लोग ग्रेड 11 केमिस्ट्री का सेकंड लेसन एटॉमिक स्ट्रक्चर सीखने वाले हैं। ओके, सो टुडे वी विल बी स्टडिंग डिस्कवरी ऑफ इलेक्ट्रॉन्स एंड प्रोटॉन्स, जे थॉम्सon's मॉडल ऑफ एटम and Rutherford's model of atom. Okay, just like the first lesson that we did, we completed the lesson and we practiced some JEE and NEET past paper questions. Same way we will follow in this lesson too. Okay, so students, you must have already studied the Dalton's atomic theory in grade 10, right? So Dalton made some postulates. He said that all matter is composed of indivisible and indestructible particles called atoms. But now you know that atoms can be further divided into subatomic particles. So it is not indivisible as Dalton suggested. Okay, so again, then he said that atoms of the same element are identical. Now we have the discovery of isotopes and isobars, which has proved this wrong. So Dalton's atomic theory was valid for a few years, and after that, when new discoveries came up, these postulates were proved wrong. Some of the postulates were proved wrong. Okay, now the breakthrough came when the subatomic particles were discovered. Okay, the first discovery was, or the first breakthrough was the discovery of electron by Thompson. Okay, so this was a huge discovery that was done, and the discovery was done through with the cathode ray tube experiment. Okay, so as you can see in the picture, there is an electrode, the negative electrode, which is called as cathode. There's a positive electrode called anode. Okay, and both these electrodes are connected to a high voltage. Okay, and there is a discharge tube, as you can see, and a vacuum pump that maintains a very low pressure equal to 10 raised to minus 3 millimeter of Hg. Okay, so that there is less gas, and this is the discharge tube. Okay, students, please remember the electrode that is connected to the negative terminal is called a cathode, and the electrode that is connected to the positive terminal is the anode. Now, this cathode and anode, they are connected to a high voltage around 10,000 volt. Okay, now sharing the whiteboard. Discharge tube, just making a discharge tube. Okay. This is the cathode, which is connected to the negative terminal, and this is the anode that is connected to the positive terminal. Okay. So this is cathode, and this is the anode connected to the positive terminal. Okay. Now, this is connected to a high voltage, and here this discharge tube has a low pressure, as low as 10 raised to minus 3 millimeter of Hg. And here, because the pressure is very low, the amount of gas will be very less. Okay, now when I apply a high voltage, one more thing I forgot to mention, this anode is perforated. Anode is perforated means it has small openings in between like this, so that is called perforated. So it is perforated like this. So it has small openings in between, okay? And also another thing, there is a fluorescent screen around, which is made up of zinc sulfide, okay? Now, when a high voltage is applied, it is seen that this fluorescent screen behind the anode starts to glow. that means there are some particles that are moving from cathode to the anode. These are invisible particles, only the glow could be seen. So that means these particles are very, very slow. So these particles move very fast and hit the fluorescent screen and they start to glow. Okay, so these rays, because the particles couldn't be seen, it was seen as rays. These rays were called as cathode rays. These rays were called as cathode rays, and because they were moving towards a uh, positive, because the cathode rays are traveling towards the positive anode, that is why that means these particles or these rays have negative charge. So that means these cathode rays are made up of negatively charged particles they named it as electron. Okay. And so that means cathode rays are made up of negatively charged particles called electrons. Okay. So what happens is that when this high voltage is applied, this cathode is made up of metals. The metals, they ionize, okay? And the electrons, they start moving faster. And because they have negative charge, they move towards the anode, okay? And because they have negative charge, they start moving towards the anode. Now, why there is a low pressure maintained inside the discharge tube? Because if the pressure is low, the number of gas particles are less. So the chances of collision is very, very less. So they head straight towards the anode, and that is why you can see, they could see the fluorescent glow around the anode or behind the anode or in the fluorescent screen. Okay. So pressure is maintained low so that the gas particles do not collide with each other and they move straight to the screen. Okay, so these indivisible or invisible rays are called cathode rays, and they are made up of negatively charged particles called electrons. Okay, and they move towards the anode. Okay, now the next is characteristics of the cathode rays. So the credit of discovery of electron goes to J.J. Thomson. Okay, so when you search the internet, it's J.J. Thomson's name comes up. Okay, now the characteristics of or the properties of cathode rays. Properties of cathode rays. The first property is they are negatively charged. We already know that. Why? Because they move towards the positive anode, positive electrode anode. So that means it has negative charge. Okay. So these rays have negative charge. Okay. Now, they travel in straight line. How do we know that? Or how did they know that? So because these experiments were happening, they were making few changes and they just kept an opaque object. Or we know that these cathode rays move in a straight line. Now, when these rays were traveling, when these rays were traveling straight, they kept an opaque object. Opaque object means something through which light cannot pass through. When this opaque object was kept, a shadow was formed. This is how they came to know that this cathode rays move in a straight line. The third and an important property of cathode rays is they possess or they have kinetic energy. Kinetic energy. So kinetic energy is nothing but energy due to motion. Kinetic energy is nothing but energy due to motion. Now, how did they know that they had kinetic energy? Now, this also, as I said, they were modifying or they were introducing. How did they know that they possess kinetic energy? Now, what they did is on the path of the cathode rays, they kept a small paddle wheel, not a very big one, but a very small paddle wheel. Paddle wheel. Okay. That paddle wheels start to rotate very, very fast. That shows that they possess kinetic energy. Okay. Now, these cathode rays are made of small particles. Because these cathode rays were hitting the paddle. This shows that the cathode rays are made up of very small particles. Now, fifth one, they have negative charge. First reason is because they move towards the anode. One more reason is that they are deflected towards the positive plate, or they are deflected towards the positive plate in an electric field. In an electric field. That means when electric field is applied, they are deflected towards the positive plate, showing that they are made up of negative charge particles. Okay. And they are also deflected by magnetic field. So they are also deflected by magnetic field. That you will, about magnetic field, you will be learning in grade 11 and 12 later in physics. Okay. So, but here you just have to remember that they are deflected both by magnetic and electric fields. Okay. Now, they also produce fluorescence. One evidence is that when a fluorescent screen is kept behind the anode, there was a glow. So they produce fluorescence. Also, one more characteristic is that they produce X-rays. They produce X-rays. Okay, so these are some of the characteristics or properties of cathode rays. Okay, so that means these fast-moving cathode rays hit the metal, producing X-rays. Now, the particles of the cathode rays, they are called as electrons having negative charge. Okay. On changing, there were several experiments done, or the experiment was repeated using different gases or the material of the cathode. Okay. Even if the material was changed or the gas was changed, the properties of the cathode ray remain the same. So that means the cathode rays are not affected by the type of gas. So that means, students, cathode rays are the properties of cathode rays are not affected by the type of gas or the cathode material. So inside the discharge tube, the gas was changed and they did the experiment. The properties of cathode rays was not affected. Even the material of the cathode was changed. Same, it was not affected. So that means these electrons are some fundamental particles that are present in every atom. So what are electrons? Electrons are nothing but these cathode ray metal, or when the high potential difference is applied, they ionize to form negatively charged electrons. And the electrons are fundamental in every atom. Now we know that, right? So that means these metal, or every atom is made up of a fundamental particle called electron, which is found everywhere. So the particles of the cathode rays are fundamental and is called as electron. Okay, now J.J. Thomson was the scientist who measured the J.J. Thomson was the scientist who discovered the electron. Now, J.J. Thomson measured the charge by mass ratio, that is E by M. E by M, charge by mass ratio, and he found that the charge by mass ratio was found to be 1.75 times 10 raised to 11 coulomb per kg. Okay. Even if the gas changed, even if the material of the electrode or the cathode changed, the charge E by M ratio remained the same. Okay, so that made J.J. Thomson to conclude that the charge by mass ratio does not depend on the gas inside the discharge tube or the material of the electrode. Okay, and it was later found out by a scientist called Millikan. Okay, by Millikan oil drop experiment. Through Millikan oil drop experiment. Through this experiment, it was concluded that the charge of the electron is found to be 1.6 times 10 raised to minus 19 coulomb. Okay, so there should be a minus sign because electrons have a negative charge. Okay, so this E by M ratio was found out by J.J. Thomson, and Millikan oil drop experiment. Through that experiment, the charge of the electron was found to be 1.6 times 10 raised to minus 19. Now, if you know both the information, is it possible to find the mass? E by M, you know, it is 1.7 times 1.75 times 10 raised to 11. You know the value of E. You can find out the value of M, right? So the M value, or the mass of the electron, it was found to be 9.1 times 10 raised to minus 31 kg. Okay, so these few discoveries, or these few informations were gathered about the electrons. Okay, so this was a big breakthrough regarding the electrons, and one of the subatomic particle electron was discovered. Okay. Okay, students. Now, okay, the next subatomic particle that was discovered was the discovery of proton. Discovery of proton. Okay. Now this discharge tube experiment was going on. Okay, so different scientists were trying different methods, or they were making some changes. They were changing the gas. So they were doing the discharge tube experiment in different ways. So a series of experiments were being carried out. Okay. Now the breakthrough came up when E. Goldstein, a scientist called E. Goldstein, discovered the proton using the discharge tube experiment. But the changes that the E. Goldstein made was that this was the cathode. Cathode was made perforated, the negative terminal, and this is the positive electrode, which is anode. This is the cathode. And there was a fluorescent material around the cathode, fluorescent material using zinc sulfide. Okay. And the discharge tube pressure, the pressure of discharge tube was not very low as before. Okay, it was around 10 raised to minus 1 millimeter of Hg. So that means the pressure was a bit more than the previous one. Okay, so the pressure was a bit more than the previous experiment. This is the discharge tube. This is the anode. So the pressure was a bit more than the previous experiment. Okay, so as usual, the potential difference is applied. When a high potential difference is applied, again, there was uh, a glow in the fluorescent material behind the cathode, showing that the rays were moving from positive to they were moving from positive to negative terminal. So these rays were seen to move from the positive to the negative terminal. And these rays were called as anode rays because they emerged from anode, or because they are moving through these perforated areas, it is also called as canal rays. Okay, so the colored rays were moving from positive to the negative terminal, suggesting that, or these positive rays were called, these rays were moving from, colored rays were moving from anode to the cathode. These were called as canal rays or anode rays. Okay, now that means these canal rays or anode rays are made up of positively charged particles. That is why they are moving towards the negative terminal. Okay, so that means these canal rays or anode rays are made up of positively charged particles. Okay, and just like electron, they also reflected by magnetic and electrical fields. Okay, so these canal rays were made up of positive particles. They were also deflected by electrical and magnetic field. Magnetic field. Okay. Now, the origin of the canal rays or anode rays. Now, here we have made the pressure a bit more. It's not very low. So that means there are considerable amount of gaseous particles, right? Now, these gaseous particle I'll make with another color. So there are considerable amount of gaseous particles. Okay, why? Because the pressure is more this time, unlike the previous one. In the previous experiment, the pressure was very low. Okay, so there were hardly very few gaseous particles were there. But here we have considerable amount of gaseous particles. Now, when a high voltage is applied, the electrons, they ionize and the electrons move out. And we are left with what? Positive gaseous particles. And these gaseous particles are attracted by whom? They move towards the negatively charged cathode. So that means they are not proton, they are gaseous ions, positively charged gaseous ions that are moving towards the cathode or towards the negatively charged electrode. Okay, now that means anode rays are not made up of protons; they are gaseous ions. These ions, the gas particles, they ionize in high voltage, and these ions, the positively charged ions, they eject the electrons, and the ions move towards the cathode, negatively charged electrode. Okay, so that means they depend on the nature of the, they depend on nature of the gas. They depend on the nature of the gas taken. Okay. For example, hydrogen. Hydrogen is very small. Hydrogen is very small. Helium is a bit bigger than that. Neon is bigger than helium. So that means as the size increases, the nature also changes. Okay. So that means here also, if we take E by M ratio, if we take E by M ratio, that depends on the nature of the gas. Nature of gas. Okay, so here E by M ratio will be more or highest for lightest or lighter particles. That means hydrogen will have more E by M ratio because the mass is more. Oh, sorry, mass is less. Okay, so E by M ratio depends upon the nature of the gas, and E by M ratio will be highest for lighter particles. For example, hydrogen, it is lighter. Okay, so it will be having highest E by M ratio. Okay, so that means anode rays are made up of gaseous particles and electrons are made up of, anode rays are made up of, anode rays are made up of gaseous particles and our cathode rays are made up of electrons. Now, since the anode rays are made up of gaseous particles and the E by M ratio depends upon the nature of the gas, that means anode rays are not fundamental, but cathode rays are fundamental. Okay, so coming to the mass of the proton. Okay, okay, so anode rays are made up of gaseous particles and is called as proton, and it is positively charged and it has a charge of positive 1.6 times 10 raised to minus 19 coulomb. Okay, But anode rays are not made up of proton. They are made up of gaseous particles, and they are called as proton. Okay, and the mass is equal to 1.625 times 10 raised to minus 27 kg. Okay, and which one is heavier, proton or the electron? Proton is much, much heavier than electron. It is around 1837 times more heavy than electron. Okay, and this was the discovery of protons and electron, and it was a big breakthrough in science, the discovery of the subatomic particles. Okay. Okay. Okay, students. J.J. Thomson proposed the first subatomic model. Okay. Now, according to this model, okay, students, J.J. Thomson suggested the first subatomic model. Okay. Now, according to this model, it was suggested that atom is a sphere of positive charge. Okay, so there is a whole lot of positive charge, and in between there are negatively charged electrons. Okay, so he compared it with watermelon. Okay, in this, the red part is the positive charge. Okay, and in between the black embedded seeds are the negatively charged particles. Or the plum pudding model is the positively charged particles, and in between embedded is the negatively charged electrons. Okay, so this was the first model that was suggested by J.J. Thomson. And he also suggested that atom is electrically neutral. Though he got the Nobel Prize for this, J.J. Thomson's model could not explain the. J.J. Thomson got a Nobel Prize for his discovery, but later this model could not explain the stability of the atom. So that is why different other models were suggested by various other scientists in this. The coming next to the Rutherford's gold foil experiment. Okay. In this, as you can see, there is a radiation source. Okay. Now, this radiation source, through this or from this radiation source, alpha particle is emitted. Now, what is this alpha particle? Alpha particle is nothing but it is compared to the helium nucleus, okay, having a mass of, now they have discovered that they have two protons and a neutron. It's as heavy as 4 AMU. Okay, so alpha particles are heavy particles. It's the nucleus of helium having a mass of 4 AMU. Okay, now from the source of radioactive element radium, alpha particles are ejected, and they are made to hit a gold foil, very, very thin gold foil. And around you can see fluorescent screen is all around. Okay. Now, this experiment was done and a couple of observations was done. Okay. So, now, Rutherford's Rutherford alpha particle scattering experiment. Okay, now there was an alpha source or alpha particle is ejected and they are made to hit gold foil, okay, and behind a fluorescent screen was kept. Okay. This was the gold, very thin gold sheet, and this alpha particle is made to hit the fluorescent screen. And there was a couple of observations that was made. It was seen, the first observation, this fluorescent screen is around everywhere, okay? This fluorescence, the fluorescent screen is around everywhere. Okay. Now, what are the observations? What are the observations? The first observation is that 99.9% of alpha particles passed undeviated. That means they were able to pass through undeviated. Undeviated. Okay. Some alpha particles, second observation was that some alpha particles were deflected by small angles. Like for example, okay. So students, you can see most of them, 99% of the alpha particles pass through undeviated. So they pass through undeviated. Okay. Now this is our gold foil. Okay. Now, very few of them were deflected by small angles. So they were deflected by small angles. I'm showing with green. So this one, they are deflected by small angles. Then, very few of them maybe 1 in 20,000 returns back. Very, very few, very, very few, maybe 1 in 20,000 alpha particles return back. That means they are deviated by around 180 degree. So that means they are deviated by 180 degree. So this means that very few of them are deviating back, but most of them pass through undeviated. Okay. So based on these observations, there were some conclusions that was made. Okay, so what are these conclusions? Let's check. So these are the three observations. Based on these observations, some conclusions were made. Okay, now what are these conclusions? Or from these, they suggested the structure of the atom. Okay. The first one, the first observation that they said is 99% of alpha particles, 99% of the alpha particles pass through the 99% of the alpha particles, they pass through the gold foil. That means this is our Rutherford model of atom based on the observations. Okay, so they said 99% of the alpha particles pass through the gold foil. That means most part of the atom is empty. Empty or hollow. Okay, and positive charge is concentrated at a small area. And this small area was termed as nucleus. And Rutherford was the scientist. It was the work of several scientists, but the discovery of nucleus comes in his name. Okay. Now, the positive charge is concentrated at a small area, which is termed as nucleus. Okay. So that is why when this alpha particles comes near the positive nucleus, comes near to this nucleus, they deviate by a small angle. Okay. Now, very few of them, they return back. Very few alpha particles, they return back, showing that this showing that the positive charge is very heavy, or there is something heavy inside the atom. So, most part of the atom is hollow. That is why most of the alpha particles could pass through the gold foil. Okay. Second the conclusion is positive charge is concentrated over a very small area. So when these if these alpha particles comes near these positive particles, they are deflected by small angles. But if the alpha particles comes head on with this positive particle or positive nucleus, which is considered to be heavy, they are deflected by 180 degree. So that's why he said there is something heavy inside the atom. Okay. For now, only proton was discovered, but that time the presence of neutron, nobody was aware of the presence of neutron. So for now, they said there is something heavy inside the atom, and when this alpha particle come in head-on collision with that, they deflect by 180 degree, or they deflect by large angle. Okay, and then there were also other conclusions like number of protons is equal to number of electrons. That is, in a neutral atom, number of proton is equal to number of electron. Okay, and another observation was that the size of nucleus is very, very small. compared to the size of the atom. Okay, that is why most of the part of the atom is hollow. Only the nucleus is very, very small compared to the whole atom. Okay, so this was some of the conclusions that was drawn by Rutherford, and the discovery of nucleus comes in his name. Okay, now coming to the explanation about coming to the nucleus. Nucleus has the proton, and Rutherford also suggested that the electrons are revolving around the nucleus. Electrons are revolving around the nucleus. And he compared it with the solar system, with Earth revolving around the sun. Okay, and he gave an explanation that the electron is revolving around the nucleus just as the Earth is revolving around the sun. Okay, now you must be knowing that when any object is moving around in a circular motion, the velocity is changing, right? The velocity changes. Now, if the velocity changes, so you must be aware from the physics point of view that whenever the electrons are moving in a circular motion, there is a velocity change. There is also acceleration. So that means there is some kind of force that is acting. Okay, and when any object is moving around in a circular motion, the force that is acting is called the centripetal force. Centripetal force. Centripetal force. Okay, now here, because of the difference in charge, the force over here is the electrostatic force of attraction. Why electrostatic force of attraction? Because there are opposite charge involved. And you know that there is negative and positive charge, they attract each other. Right. So that means the electron should come very close to the nucleus, or the electrons must be pulled up by the nucleus. So that means the atom should not exist. But here what is happening is that because the electrons are moving in a circular motion, the electrostatic force of attraction is converted into circular motion, which is nothing but centripetal force. Same like that of sun and the earth. The earth is attracted to the sun by what? Gravitational force. So this gravitational force is converted into what motion or what force? Centripetal force. That is why the earth is moving around the sun in a certain orbit. So similar way, this electrostatic force of attraction between electron and proton, the opposite charges, is converted into centripetal force that keeps the electron revolving around the nucleus. Okay? So that means F electrostatic equal to F centripetal. Okay, so this was the explanation that was given by Rutherford. Now, there was some drawbacks here also. Now, here, the drawbacks was, the first drawback that was pointed out was that the first drawback that was pointed out was that this model, Rutherford's model, could not explain stability of atom. Stability of the atom. Why? Because that time Maxwell gave a theory that, according to Maxwell's theory, any accelerated charged particles emit radiation. So here, electron is a charged particle and it is accelerated. Both these conditions are met. So any accelerated charged particle must lose energy. So definitely, if anything, then if energy is lost, that means it should fall and it should be attracted by the nucleus. So that means the atom should cease to exist. That means atom should not exist. So Rutherford could not provide an explanation for this. And also, the second point that was pointed out was that Rutherford could not explain the line spectrum or discrete spectrum of atom. About the spectrum, we will be learning more about it as we move on in the topic. So these were the two drawbacks pointed out about the Rutherford's theory. Okay, so